Hey everyone, welcome to another episode of the Common Lisp Study Group. I'm your host Ram Vedam with Atlanta Functional Programming. Last week we started exploring a library called the Adopt library, another library for command line parsing of Unix options inside Common Lisp. Today we're going to be continuing our discussion of this library. If you recall, just to give you a brief summary, we started with kind of talking about UIOP first, and then showed where Adopt kind of got its role. Adopt, just as a quick introduction for the folks who didn't join us last week, is yet another parsing library for Common Lisp that parses Unix-style command line arguments. But it's not only just it's inspired based on the argparse and optparse libraries that are available in Python and Haskell, respectively. The design of Adopt is very, very similar in nature of another library that we've covered on this in this series, which is the Unix ops library. And we're going to see some pieces of it today as we continue on our exploration of this library. Compared to the other approach that we were covering last week, which is raw command line parsing using UIOps /image, which provides you better flexibility in the sense that it is more portable across different implementations. Additionally, it is widely available, meaning that it's one less dependency that you don't necessarily have to add to your ASD file for, or in this case, we're using Roswell's scripting format to actually go write like a Unix script to create our example program here. Adopt actually provides something very similar in the optparse sense, in that you could create different options, both long and short options, as well as the ability to group actually options into simple groups for better like documentation purposes and things like this. Now, there's a couple of things that I wanted to briefly mention before we really hit the ground running today. Just one particular announcement in Administrivia, and that is next week something has come up, so I'm unfortunately had to cancel our next stream next week. So folks who are joining in, we will be on a brief hiatus next week for the Common Lisp Study Group stream on Saturday. Additionally, for folks who are going to be joining us on Sunday too as well for the Haskell Study Group next week, that's also going to be canceled. So last time when we created our Adopt program here, and this is the simple Echo client that we've been following for our Echo server program that we've been writing. And let me just start that up here just for so that we can actually do some real like demoing later on. And you know what? It'd probably be better to do this in eShell just to get the application running is really what we need. So let me just do a quick ROS build of this guy just to make sure I didn't miss anything. Okay, so we start our server. Okay, now we can close this guy. All right, so if you recall, adopt kind of has a different structure for how it handles, building up a user interface for command line parsing, for a command line, okay, for a textual interface. It has a macro or function here that I think it's a macro. No, it's my apologies, I forgot to first load. So this is a function that basically takes in our keyword arguments here, and the first argument there specifically is actually the name of the option that you're going to be creating, and then you have some options related to whether or not we have a short option or a long option. Some basic information that's going to be passed in and displayed when you do dash help, and this third thing, which is the reduce, which is dealing with more like once we've actually parsed the option, how do we normally, grab the information from it so that what is actually returned once it's actually getting parsed. Okay, so what that means is in some cases, if you have, say, Boolean options, you would end up probably just constantly returning a true every time this value is set, so you don't necessarily have to parse the next value that's coming in inside the stream. Okay. Given this kind of option structure, because if you recall, when we actually just do this first, which is okay. So if you recall, our the return value of the option that we have here, like in the case of option help, will be an actual option object that holds, the information that we just obviously set up. Information for the help menu, what is the key to determine what's been set or not. This reduction that's ultimately going to be called every time the argument is parsed, and so forth. Okay. And we've seen last time also that, given a set of options, we could create a UI, a make interface object, which will take in the name, the summary, how it's going to be used, and this is all generated together into a single utility when we actually go and display it, and we get the help text that we set up earlier here, that we have the ability to actually make multi-line help text using adopt defined string. And we talked about also how we set up the list of options that we created, and it's a combination of stuff that you could have provided globally in the case of option help versus actually inside the contents, which takes a list. You can actually construct your options individually inside here. Okay, and we also saw last time that there is this this ability with the reduction, especially when you're reducing these arguments, to take in a lambda that could take the previous value and the new value. And we saw that if you're especially taking in string arguments, adopt provides something called adopt : last that will always allow you to take the last option that's been parsed. It doesn't keep track of the history of the previous value that option was originally set as, and so forth. So there's a lot of flexibility here in designing your interface, and so forth. We also talked a little bit about how Adopt provides this ability to generate a help text or print a help text upon exiting the script or the application. So if you're invalidly setting up things, you could just do print help and exit, and you could appropriately return the non-zero error code that's required in order for it to be thrown out to like standard error and so forth. Because if you recall how Unix programs work, upon success, normally you return zero or return success, depending upon if you're using the predefined constants that are available, and I think it's in unistd.h for success or failure. So given this, we have now our kind of structure of building the basis for our command line application. There are a couple of things that I also want to briefly mention, which is the fact that, and we saw this last time in a little bit, in that we could generate the man pages, that we can actually set up our man pages to be generated by our program, so that upon compilation you can actually have a final generated man page that's actually integrated with the rest of the system, and you can actually copy it directly into the location where the man pages are, which is depending upon your Linux distribution, the man pages location is somewhere in /lib. I don't remember all the details, unfortunately. But it's usually in a directory called man, and then you can actually put in your man page in the appropriate place where you feel that it could be fit. I defer you to folks who are writing utilities like this and probably going to leverage this functionality to go look at, I think in the GNU reference page on man, there is a distinct section hierarchy on determining where you should put your appropriate utilities. So I defer to that documentation for if you have questions on, should it be in section 3 or section 7 or section 4 or something like that. Each of those sections have a specific meaning, and I'd rather not crawl down that rabbit hole, just because it's not a particularly interesting topic and related topic to what we're going to be writing for the rest of our session today. But it is certainly something that you want to be aware of, just because it does have implications when you're talking about usage with putting your utilities inside man. Okay, so we've already looked at some simple, we've already created our UI here, which is the basics for actually constructing our interface. And you've actually seen, using print help, our UI. And remember, if we have to provide different program name, echo client adopt, when we're using we're interactively developing this inside the REPL. And we've already seen that this kind of generates our basic client, and it gives us the appropriate display for options that you're going to be displaying. And given that we've actually wrote after content a set of examples on how to use this application, we actually went ahead and also spit out a bunch of examples. But we didn't actually go and talk about, well, how do we parse these options? What is actually the process of parsing these options, right? Because that's obviously the use case that we have to consider. So given a set of options, and we have this ability to, we've already created these options using our make interface. We're gonna get started on talking about, well, what exactly does it mean to parse some of these options, okay? And to do that, we're going to be using the function adopt parse options, okay? Parse options is what you would use to actually parse it. And there's two kinds here, okay? You have the ability to parse options, um, uh, and in this case, you would probably there's it returns two values. One is the list of non-option arguments that are your values, and one is well, it's non-option arguments which is your command line arguments that are passed in that are not actually options, um, and a hash table that contains the options themselves, their keys, and based on their keys and values that you've already provided in the option objects themselves, as you can see here. Okay, and we're going to go through the example that we've already provided here with this, because one of the nice things about parse options is you have the ability to actually pass in your interface object, and then since you can see here, it can take in the rest arguments. You can actually pass in the list of what you're really passing in is a list of all the parsed options that were provided. Okay, so just to make this simple, although we don't have anything necessarily to use an input that isn't a command line option in this case, because we're writing an echo client, I'll go ahead and obviously just write this for illustration's sake. For folks who may be wondering if you could do that, yes, you could certainly take in this value, for example, and if a value was provided after the parsed options, then obviously that could be used as, say, the packet that's actually sent to the server once you connect it to it. Right now, we haven't actually implemented a lot of that for the case of our adopt program. But let's say that we passed in a couple of options here, and I'm going to inadvertently forget to pass in our required option, which is the host, because obviously this client's default value for connecting to the host is already on the port is 5,000, and we could certainly pass in a default value of localhost if host isn't provided. But I'm just showing this as illustration's sake, just to see what's going to happen here when you do this. Okay. Actually, let me first show you the real case, and then we'll talk about that second one, because that one's going to be talking about exceptions and sorry, not exceptions, conditions that we need to probably handle when we're working through the condition handling part of this library. So as you can see here, when we passed in our options, you could see that the options were all thrown into this hash table. If we look at this hash table, you see that the hash table will provide all the options that are built into our interface object. Okay, so every option that's already there. So that means in this case it's including help, even though it's not passed in the command line. And it will give you these values. So what you're going to have to do is you're going to have to, at least in this case with adopt, is you're going to have to check to see if a particular flag is set or not. Okay, so obviously in the case of help, because it is a Boolean option, it's going to it's okay to have this nil value, because nil values are going to be considered false. So you would actually be able to ignore or safely ignore these Boolean values here. Okay. Additionally, we saw that it took in this this foo argument made a single list of values that are being provided here, right? And this isn't just for foo. I mean, you could pass in as many of these arguments, and it's just going to make them as a list of packets. So you could see, in a sense, this gives us some flexibility, especially if we're trying to write, say, a client that is connecting to some sort of remote network server, and we're trying to pass in multiple packets at the same time. This gives you the ability to now send different messages and different packets to the same destination without having to specify a delimiter to the actual code to actually indicate that you want to pass in multiple values now. So this, in a sense, gives us a little bit more flexibility to play around with what we need to ultimately get in from the input or not. Well, let's say though that like before, that we don't provide a host here, which is a required argument that we made here. What happens? Well, it actually, in this case, set it to no. So this is actually wrong. What we need to actually do is, in this case, is we need to actually set it up so that it is required. So that means we need to make it so that this option is cannot be not set by the options, and in doing so, we will be able to see missing some of the exceptions and conditions that are going to be thrown here. So we have to go back to there's a flag that must be missing in make option. Let's see, required help short string. Function designator, finally. Alright, there is one thing that is missing here, which is where is make option? Must have. Let's see here. This doesn't look like it has a required thing, but it should be required because they have an unrecognized option here that could be. Let me see. There might be some conditions that I mistook when I. And that's gone. So Alright, so I just saw, I misread this, my apologies folks. So it looks like adopt does not provide any way of actually doing required arguments. So we're going to have to um, mimic some of this to give us what we want. That's not a big deal for our parsing options. So, okay, I rewrote this wrong in my notes. So let me just update the notes and let's go back to what we're doing. Okay, so to mimic required arguments, so there's a question, could we just set a default value? We could certainly set a default value, and that's fine. But what we want, what I was trying to show is if something wasn't set. So if you look at the older parse library that we were talking about a couple of weeks ago, UNIX ops, it had the ability to say this is required and to throw a missing option exception, or sorry, a condition that we can actually handle using our handler case. In this case, we're going to have to mimic something something a little bit. We're going to have to actually write in our reduce if no value is provided to throw to just throw not an unrecognized option, maybe a problematic option. So there's a slot that you can use to actually go in and to write an option to say something has been missing or not. So it's just a little bit more work to actually go and handle that. Let me see here. Let's let us move forward because that is okay. I will handle that when we start talking about the other case, which is we throw options that don't exist inside our code. The other thing that you would see typically is either, in this case, like you saw here, either you get something that isn't set, where obviously like help, we're going to end up having this this set to be nil. In this case, in the case of our Echo client, we don't want this. We want actually some ability to actually have a default value. So this can be easily fixed by just providing a default value into, as was suggested, with localhost. And this actually fixes, sorry, this actually fixes this. So now if we go and click and do this, and we don't provide anything, you'll see in our hash table that we're introspecting that we still set the default value. So that's okay. That's fine. But there might be a situation where you may have, set a value, say this to be -t, or it's an unrecognized option, okay? Or better yet, you wanted to pass in -port, you said PRT instead of port, okay? You had a typo when you were typing it in. Okay, so there was a comment, does not seem required if a initial value set. Yes, so the comment was if I'm going to set an initial value, then it's no longer a required argument. You're absolutely right. I could update this and say that this here is no longer required. Really, we want it to be required so that we have some some parity over. But for now, we'll go ahead and say that the host name is no longer required for the time being. But to continue my example here, if we have this typo and it's an unknown option, when we throw this, we're going to end up getting something called unrecognized option condition. Okay, so adopt has this ability to say, okay, if it's not in the list of keys that I've already am aware of, go ahead and uh, give me this a couple of the following restarts. Okay, and we see a couple of restarts here that you don't we haven't actually talked about. Recall how restarts work. Restarts has an ability to give us some way of recovering from uh, our exception that was thrown, while maintaining the stack trace at the point that the actual error occurred. Um, and the following options are available to us for discard option, treat has argument, and supply new value. Each of these will take the string that's in question and allow us to do a couple of things. The first one, obviously, is self-explanatory. It'll just go ahead and discard this guy, okay? And we can try each of these restarts to show the functionality. In this case, what ends up happening is it gets eaten up, and we end up getting 5,000 as being part of the list of data that's being passed into our program has a set of inputs. And obviously, if we go and explore this guy, they're set to default values. To make this a little bit more consistent, because our default value is actually 5,000 for port, let's go ahead and make this 8,000 for clarity's sake. The next thing that is restart that we have is treat has argument. Treat has argument basically is saying that, you know what, this is actually not an option. Go ahead and treat this as another part of the input, okay? Because although it looks like it's an option format, it's really not, okay? So if you're telling it to ignore the parsing logic and just treat this as part of the input data. In this case, if we go ahead and say treat this as argument, again, as you can see, we now have our port option available inside our list of input data that's being passed into the program. Finally, then there's our last one, which is supply new value. Here, obviously, you have the ability to take this restart and change it so that this can be a different value. So in this case, what we'd want to do is we could just say that this is -- port, and you can see that now here, if we go and look at our thing, it recognized the long option, recognized the argument, parsed it, parsed the integer, and then returned it inside of our hash table. Right? So you have several abilities to handle this. Now you could certainly inside your top level write a lot of this stuff so that we can handle these unrecognized options the same way. And the way we would do this is we're going to update this code here with that particular case, and then this way we are able to actually try a lot of this out on the command line ourselves. So the way we would do this is just like before, and this is much in the same line as our example that we saw in UNIX ops. And to give you a brief review for folks who haven't seen that, it's much the same logic here that we would have to do. down in our main thing, we'd have essentially a handler case to actually go and handle um, the situations that we're going to be dealing with when we parse our options. Now, one way of doing this, I'm going to change the code ever so slightly. Instead of doing the multiple handle value binding to the handler case, I'm going to actually switch this around a little bit. This way, we could see the exceptions that are going to be thrown and provide some additional advanced errors that are actually available at our disposal, right? Inside the UNIX ops, the adapter library. So the way to do this is we write handler case, and then we go ahead and we specify, what is. Remember the form that we're going to be dealing with. We're dealing with the multiple value bind, and we're grabbing the what I would be calling the input data, and then I'll call this guy the options hash. And this is being returned by adopt parse options. Okay, and we're going to use this for a second. Although I'm going to just briefly mention for folks who are kind of wondering what this guy is. This is essentially the same idea, except parse options just exits out. This guy just literally exits the program. All right. You can actually provide let's say -p 8000, and you will see that this is going to be giving us the same idea that we had before. Right? Give a second. Okay. There's one more thing that I forgot to mention before we start this handler case example, not just the UI exit thing, and that is in our case that we had before. Okay, recall that. Let me just go ahead and change this to this. Recall that we have our data inputs, and then we have our options here. Okay, and obviously the order doesn't really matter. Like if you change the ordering here, sorry, you change the ordering here, and it will essentially be treated the same. But if we had this previous order and we started using this, and this is typical for a lot of Unix programs, where you're basically telling that dash that the remaining arguments are textual arguments. This is actually built in to the adopt library, which is really nice. You don't have, it's not treated as a special option. It is this normal functionality that you're normally available in most argument parsing libraries. This feature is actually also available here that you saw. So not only in the case if you're trying to discard the argument and treat the argument, and treat as argument conditions are available, or restarts are available for you to actually handle some of the mistypings. If you do know that something is actually going to be an option for the inner program, say you're using this outer shell to actually wrap an inner program that you're actually going to be executing. You're passing in the command line options for that program. In that case, you'd want to use this dash option instead of trying to do a unrecognized option and then defaulting that with the supply, sorry, not supply new value, treat as argument restart as your default handler bind case that you would end up dealing with, which you would normally do with other cases, but in this case it's not necessary. Okay, so let's get back to this thing. So we now have our options, okay, and let's say that we are just going to print out what was available. Okay, so we're going to print format T, and we're just going to pretend we're connecting to our server right now, colon port, okay? And obviously here, we're going to just grab the options that are provided. In this case, since we're using default values, it's okay to actually just do the straight up get. And obviously to do this, you just do get hash and then the key in this, and recall the key for these guys are just basically the symbol values. So in our case here, we're just getting the host. Inside our options hash table and the port. I'm just going to go ahead and print this guy out this way. Okay. Get hash port options ht. All right. Okay. So this is no longer needed. Let's go ahead and delete this guy, and we are now golden. Input data is never used, right? Well, for the time being, let's just say we're just going to ignore the input data for a second. Well, I'll do something else. Let me make this a little bit more complete. Okay, we're going to say that we pretended that we connected, and then format. And later on, we'll obviously fill out the skeleton of this and send these values if there's anything. Loop for item in input data, do format T sending packet message. Okay. Item. Okay. And that's good. All right. So we now have our simple mock program that will handle some of this. All right. Here, if we go ahead and compile this, let's go ahead and open up a new shell. Start up another shell. Fine. Looks like I'm going to have to start different shells. And in this case, let's do ROS build, echo, find, adopt, laptops. Right. Okay, and our compile works, and then obviously if we just do client.adopt, you'll notice that if we don't pass in anything, it's going to attempt to use our defaults, and obviously here it connected it, and then it printed out that we connected, and if we pass in data, obviously it's going to attempt to connect it and then send us our foo and bar. Okay. But let's see what we would have to do when we want to pass in additional options, right? Because that's obviously options that are unrecognized, like if we have typos and stuff. This is the common use case that you would normally have to handle for. In this case, obviously you're going to have to provide a couple of errors, okay? One, and let's go back to the program. Let's do echo client adopt. So here, although the code for the basic stuff is here, we haven't actually completed a couple of things. So for example, if we pass in a wrong option like we had before, BRT then 8000, it's going to end up throwing this error, obviously. So we're going to have to handle this this unrecognized option thing. Okay. So in order to do that, we're going to have to first, in our handler bind, and let me do this to make things a little easier, which is, let me close this guy for a second. Okay. So here, what we would have to do is two cases. One, you can have a generic error case here. We could just say error C, and we could then use the function print error and exit to actually throw the actual error. Okay, so if you want to see what this guy is, this is a convenient function that adopt provides that basically allows us to take all unrecognized options and just dump them out. Okay, this is essentially what we're using, and all it does is it will dump the error stream to our exit. Okay, so let's do this and just see what happens. Error, exit, our function, and obviously this is now recompiled, and we obviously want to go in here and this, go into our shell. Okay, and recompile. Okay. And when we run this guy, it'll just go ahead and throw an error. All right. So in here, in this case, what it's doing is it. Let me see if I can actually do this. 1 second. I'm gonna see if I can get a proper. Because eShell is a nice. Well, how do we start a new eShell? Let's see. Well, I could do this. Let me pass in this. I'll go ahead and start this guy off here. Okay, so, and I'll kill that later on. Okay, so if we run dot slash echo client adopt what we had foo bar dash PRT. Okay, here you can see what's actually returned is this following error option. Okay, I wanted to get all that noise. If you guys use shell on Emacs, sometimes there's quite a bit of noise when it's trying to interact with standard out. So the actual error that it's actually returning is that there's no such option dash PRT, which is kind of already simple enough. You can use this kind of error handling to deal with the incorrect argument parsing, because obviously you want the people to be able to write the correct command line argument. Additionally, you could also do like a handler bind. You could have actually wrote the physical option like that's written here. If it's unrecognizable, instead of taking generic error, what we could do is we can actually split this up, go back to Ross, and in here, instead of doing this, we could just simply say adopt : unrecognized option, and this essentially does the same thing that we saw before. Okay, so if we go and build echo client adopt Ross, you'll see that at this point it's going to build up, and when we run it, we'll end up getting the same error that we saw here, which is useful. It gives you the ability to now clean up some of the structures here, and then shoot. Right. And you get the same error, right? Obviously, we have one more option here that we're not actually dealing with. So let's go ahead and complete this example of printing things out, okay? And that is, if let's say we accidentally, in our pursuit of actually parsing some stuff, we mistakenly used dash lowercase h for providing the host instead of dash capital H. Okay, this could happen when you have multiple, especially when you have multiple options that use the same letter to actually pass in to your command line. Okay, in this situation, you want to first check to see if the help option was provided, and if it is, go ahead and then dump and exit out of this. Okay, so in this case, you could just simply say, when, since this is a null check, option HT. Now I'm using the -HT as a shorthand. You don't necessarily need to put that for your hash tables if you realize what type that is. There's a shorthand I tend to use when I'm writing some stuff inside Common Lisp. You could then certainly use print help and exit and you can use this to actually go ahead and pass all your command line options. Okay, and in this case, you don't if you're compiling on the command line, you don't necessarily need to provide the program name, because if you look again inside the signature, program name is already defaulting to the car of the adopt of the argv. And argv, it holds everything, including what program was invoked in order to get the options. And so we just need to keep this as is. If you want to change the error code, you may certainly do so. I don't think it really matters if they passed in a valid command line option to do a successful build, but whatever makes your application more usable. All right, and obviously if we pass in this now, if we do -h -- PRT 1000, if you think that we would be hitting that second case, well, actually, let's do that. It's going to actually, if we pass in the correct command line options and we pass in for help, it's going to actually go ahead and dump the help out, even though we've also provided a valid command line option here, right? All command line option parsing libraries provide some sort of ability to deal with different types of options, and we've actually talked a little bit about the different types of options that are available here. But after last week's discussion on some of the options, which I thought were considered Boolean flags, things like --help, and if you have a version, you can certainly provide a version as well that does something similar to what --help does, which and the only reason you'd put to spit out a version of the code that you'd want, so you can. But there are many other options that you may want to consider. If you look at command line utilities that are normally built inside Unix and Linux in general, there are options that deal specifically with Boolean flags, but they're separate options that interact with the same Boolean flag. An example of this is like, say, if you're trying to deal with get's paginate function, or where you have either paginate or no pager, depending upon what is passed in, a simple Boolean flag for pagination is set. You have options like SSH is -v that deals with how many times a given effect is provided, like so the level of verbosity that can be dumped to the logs. Those options have to be supported. You have options that take in a single parameter, like we have here, like in the case of host and port. But you can also have options that are that collect everything. So that means everything that's passed in inside after the command line option is part of a single list of potential patterns that you'd want to leverage. And this is commonly used in, like, say, rsync or other regular expression like libraries, where you may want one or more options passed in to a single parameter. So optparse and argparse so argparse, like in Python, for example, has a way of handling this by providing a way of handling the various cases with a different set of actions. But we talked a little bit about what the reduce value does. It takes in the option that was passed in, the option value that was passed in, and it will actually parse that option based on the lambda function that you provided here. And we gave an example of this for ports. Well, this is not entirely following what adopt provides you. It gives you a little bit more flexibility than handling everything in a single function. And we're now at a point where we can now I can now discuss this a little bit more in detail. So in order for me to bring this, we must understand how arguments are actually from the time the program is invoked, how adopt handles arguments that are being passed in on the command line. So before anything gets parsed, all right, when we construct the hash table that's ultimately going to be returned by parse options, and this is probably pretty obvious, all your initial values are set. Okay, so think of this as just constructing the hash table with initial flags all set. Okay, if there is an initial value for a given option. All right. Then what we would do is we will take this reduction function, okay, and when you create an option, you take this the reduction function that you provide, okay, and that function depends on two things. One, if you are a flag, like a simple option, like in the case help is, all right, and I'm not talking about like a Boolean option that has two different parameters, two options that essentially affect the same Boolean flag inside your program. If you're dealing with a simple option, what would happen is the reduce function that will take it will just set whatever the reduction function that you provided and use that to set the value inside your dictionary. But if you are a option that takes in a parameter, I know this sounds a little a little bit more complicated than the other options parsing libraries, so bear with me. If it's a parameter taking option, then it'll take the current value that was that's inside the dictionary, which is probably normal. If an initial value is provided, it'll probably be whatever the initial value is, all right, or nil, and it'll take in the new value that's provided by the user, as we see here, and then we go ahead and be able to deal with that to interact with the command line option and parse that command line option. Okay, but after that you have another thing. All right, you can also provide an additional function that can be called on the final value. So finally here, let's say that instead of doing parse integer inside here, and let's just say that we return new, okay? Instead, let's say that instead of doing this, we have a finally that actually parses it, okay? So we know what the initial value is. We could check to see if it's an integer if we wanted to here, and then parse it instead of calling parse integer directly inside of the function. But this finally is what's ultimately going to return the value of the option and instantiate, stick it inside the code. Now, if all is well, you would end up getting the same. Actually, I don't even need to do this. I can just show you guys on inside the REPL. You will get the same thing that we had before. So when we do parse options and we do --port 8001, you will end up getting a dictionary with 8001 as being your thing. So you notice that what happened is we're just, in this case, in this case here, we're just returning the options. If you're doing something like this, and we wrote something like this, you could also, do adopt last here, and this will be the same thing that we had before. And you can see that this doesn't change anything; it'll still give our parsing logic being the same. So it cleans up a lot of stuff. But if you want additional validation inside, what you would want, like let's say that you want to do a type check here and verify that the type of that's being passed in is of type integer or something. You could certainly do that, and it'll give you some ability to do some additional validation prior to do a final parse of the value that's being passed in. So the adopt library gives you a lot of flexibility on how you would interact with and how you would deal with different types of options depending upon the types that you're dealing with. Okay, and it allows you to make a fairly complicated let's say command line user interface with your options that are available. I'm going to just briefly show you two things related to this Boolean flag because I thought this was pretty neat, which is dealing with the same flag inside the adopt dictionary, adopt hash table, right? So let's say that, we have, we want to have silent and no silent to determine whether or not we are silently sending some data over the network, because we in our example here we are actually throwing all these different like debug messages into our program. Okay, so let's create two options here. Okay, one to turn on debugging, one that turns off debugging. Okay. Obviously, you could do the same thing by doing a check in using a single parameter, but I'm just using this contrived examples for simplicity's sake. Well, for the sake of illustration, I mean. So here we just say silent. Okay. And we could also use the verbose flag too as well, but it's going to be it's ultimately going to be the same idea. So we have two flags here, one saying option verbose, okay, and option silent, okay. And in our option verbose, we're going to go ahead and call adopt made option, okay, and we're going to say verbose. And we're going to go ahead and set up our long key verbose short the character -v. Then we'll have a simple help parameter that will say turn on logging. And what was the third thing that we need to do? Oh, we need to provide some reduction function. And here we're going to say that this is constantly true, right? So we have this very simple flag that does nothing here, okay? This is similar to our help flag. You can see that it's not really doing much here, okay? This is where, though, it becomes really, really interesting, okay? Recall, so let me first finish off what we would do here, which is silent, okay? And again, on silent, short, -s, help, okay, and this guy is producing. Okay. So far, what I've just done is I've made two options, both of which that we're going to add to our list. Option verbose, option silent, that aren't actually connected to each other. Okay, they're treated as two independent options. All right. This is really, really nice, okay, and this is something that I come to appreciate when I started looking at this library. If you recall, make option has a bunch of other stuff that we haven't actually touched in terms of keyword parameters, right? And just to show you, one of the two things that I'm going to be talking about is specifically related to how it interacts with the hash table, okay? If you remember when we went through going through make option, one thing I mentioned is result key. All right, result key was essentially the key that's ultimately being used to interact with the hash table when an option is parsed. And by default, each option gets its own result key. Okay, and that's where it's getting it from the name that you passed in. Okay, that symbol that you passed in. In this case, silent gets one and verbose gets one. If you want to override that, which you could certainly do, you can actually just provide this. And by doing this, you're explicitly providing a link between the previous, the two different options themselves. Okay, so in this case, we're basically saying we have verbose and silent, but when we're using silent, really we're interacting with the verbose entry in our hash table. All right. And by doing this, you've essentially created now the ability to, when you parse the options especially, just to show you. Okay. Yeah. Okay. Good. Let's do this. Sorry about that. I forgot when I changed this logic to be this way. Really, I should have actually moved that along. Okay. Parse options. We now have another entry. Obviously, here we're setting verbose to nil because that's what it's going to be its default. If we do obviously -v, we're going to get nil is true. And to really show this, though, I'm going to go ahead and do -v, then -s, okay, just to see what happens. You can see we turned it on and then we turned it off, okay? And obviously to show this ordering, you can see that if we change the order, it is set to true. The key thing here to note is both of these options are interacting with the same hash table entry. Result key gives you this ability to be able to create an implicit connection between different command line options, parsing flags together, which I thought was kind of useful. It's definitely useful for different cases. Adopt and this is something that we saw earlier, and I didn't find the section here until when I was trying to debug something else earlier during the stream. But adopt doesn't have a concept, doesn't believe in the concept of required options. All right. Main reason is the author of the library believes that the phrase required option is an oxymoron, and because there are many situations where you want to ask for command line options available to the program, not providing additional command line options. All right. What I mean by that is it should not, when you're parsing options, but the user doesn't know what options to parse, oftentimes they're going to probably just start up a program and do --help or -h. Okay. If a program requires certain options to be available or options to be provided in the command line before it gets parsed, all right, and this person is giving this end user is providing --help because he's trying to figure out what options, and he gets an error, he'll be wondering what's going on. He thinks that there might be a bug in the program. All right. He shouldn't get an error though when they're about a missing required options in that situation because they provide --help. All right. They're asking for the program to tell him what customizations could we actually pass in. All right. So in that case, what I was saying earlier, we can mimic this because you could just simply check to see if the hash is nil or not, and then we could simply provide an error or an appropriate error saying that you need to provide a host name to connect to this guy, and you can get similar functionality to it. Okay, this is one difference between adopt and Unix ops in terms of their approaches in getting inspired by the argparse libraries that they're both that family that they're coming from. We could, to illustrate this, I mean, really, this should be pretty straightforward for folks who are now comfortable with the Lisp code. We just need to simply provide an error here. I'd say unless get hash host, throw the following error message saying you must provide a host name with the -h option. Okay. And then oops, 83. Go back to here. Sorry, I didn't realize I had caps lock on. Okay. And I don't know if this, I don't remember if, I think error actually will exit out of here, so I can't actually provide like print help and exit. Okay. And we can just do this, and now we essentially have the same thing that we had before. In our help text here, we can now say that this is now required. It's essentially, but again, like I said, this is the author's belief is that we don't need, or we shouldn't really ask for users to provide certain required arguments, especially in the case that they need to know what arguments need to be passed in. That's just a design choice that the author leveraged. So in this case, we can go ahead and compile this, and we'll see that if we don't provide a command line option, we'll get the error message. Now I could have mimicked this inside the REPL, but I thought it would be more appropriate to show you what happens in the command line in this case. So now, if we run some of this stuff, get rid of this stuff, you'll see that you'll get, wait a second, that's weird. Oh, that's right. My apologies, I forgot to get rid of the default value. 1 second. Okay. So now if we go and run it, you'll get the following error message. And in fact, it throws, yeah, this is a little bit more uglier because we need to actually get more appropriate error message. So what we'll do is instead, we could certainly mimic this by saying, instead of this, we will use no. P, okay. And then we'll just say adopt print help and exit for our UI. Right? Done. And we'll specifically say this. All right. And if we run this, obviously you'll get the help as we expected, but you'll also get an error. You must provide help with things. And you could do something similar to this with, you know, you could add an additional new line or whatever. You can do something similar with all the other options that you want required, but really, if you're trying to adopt this library and stuff, I think following the philosophy that it's indicating at least would lean towards more usable command line options. Command line programs that have a more consistent interface where --help actually provide you the options without you having to actually provide additional options as a requirement for --help to be parsed successfully. And you don't have to worry about, the man page, to go into the man page. And the man page becomes more documentation that you could certainly use. So one final thing that I'm just going to briefly mention here, we don't have really related options, but it's certainly something that can occur. You have this ability to actually group related options together into a single group that will help, better print out these options when you're printing the help text. And so when you do that, you end up getting this specific type of object. I'm just going to show you here for the sake of example. Let's say that you created, you want to create a group called network options. All right, and here you are providing title, connecting to remote host. Okay, and then here we'll just say these options affect how we connect to our remote echo server, and you provide the options. As you can see here, let me just bring back you have title, help, manual options. All these are key value options, and as far as I know, they're all required, especially the : options one. And this one will take in, our two options that we have host name and port. Although right now it's an empty list, we can certainly mimic this up above once we provide it. I really wanted to show you that this group option stuff is essentially similar to that of the options object. So once you actually have this constructed, you can actually pass this in as a single section, and we'll go ahead and generate that for you. So let's do that very, very quickly. Let me just take this guy, move this up here. Okay. And let me go ahead and do this. Okay. And go ahead and make these into their own options for simplicity's sake. Grab this, the parameter option port, okay, and then get this guy having option host. And so that's all properly indented, and now we can actually go ahead and add this guy here. Option host, option port. Okay, so now we have our network options. Oh, sorry, I forgot to compile option for host. Okay, now this is there. What? Okay, so we got our options, and now we can also make one more group. Let's call this guy our logging group as well. And this is going to deal with our verbosity options, right? And so this is actually, let's say verbosity. And this will take in the title, logging, call this logging options. Help these options. The console. And the options that are provided are going to be option verbose and option silent. Okay, so we now have that, and we can go ahead and clean this up a little bit here. Cut, and we'll add our network options. Oops. I forgot to make these into variables. Let's just go ahead and make these into variables here. Our network options. Oops. Okay. That's compiled. And here, the parameter. And so we now have that. Network options, velocity options. Okay. So one of the nice things about this is once we have our options, let's see what happens when we actually print our help. Okay. Adopt, print, help, UI, program name. Okay. You can see immediately some changes to our help text. Okay. Each of these groups get their own section. Okay, which is really, really nice. As you are building up your command line tool, as you're building up your application, this kind of grouping makes that much difference in terms of usability, in terms of making your command line tool far more usable, in terms of managing the man page, managing the documentation, setting up all these kinds of things. And you don't have to do additional work. It's generated for you. I think this is really, really useful, especially for folks who are making very complicated command line clients, like your Docker derivatives or your Kubernetes derivatives and so forth. And being able to do this all straight up in Common Lisp in a very clean fashion using the simple design, I think it speaks volumes in terms of how useful this library is. The final topic that I want to mention about adopt is just some specific things related to some stuff that I noticed in the manual. And a lot of it is related to folks who are directly dumping their Lisp images via their Lisp implementations image dumping functionality. So like if you're using SBCL, you might be using save Lisp and die directly and so forth. If you're doing that, the documentation does mention that you're going to have to turn on explicitly save runtime options and set it to true in order for you to handle passing in these command line options and preserving them in your ultimate executable that gets generated. Now, you may have noticed that I didn't have to necessarily do a lot of that because I was using Roswell. That's because Roswell handles a lot of the generic implementation-specific details for the given Lisp implementation that you're using. In my case, my default is SBCL, so behind the scenes, anything related to SBCL is already handled for me. It's one of the benefits of actually setting up your Roswell scripts, and I still think today that that's probably a better way of just handling it rather than having to worry about your Lisp implementations, configurations, and so forth. Now, additionally, for folks who are using ClojureCL, the only thing I can mention is I defer you to Steve Losh's usage documentation because there's a section where he specifically refers to a GitHub issue revolving around ClojureCLs, and that's mainly dealing with a global variable, a special variable unprocessed command line arguments that is there that for some reason is nil when you're running the actual image itself. Now, I don't know how this library or even other libraries work around that particular issue, so it is something to be aware of for folks who are using ClojureCL. SBCL folks, the only thing is safe runtime options, and as I said, I think you're okay if you're using Roswell. I have not checked to see if the same thing with Roswell, if Roswell handles this stuff for CCL as well. That is something I will check later on, and I may provide a comment in the YouTube comments regarding CCL once I have that resolved. So that's it for the adopt library. I think you guys would enjoy using this. It's a very simple library based on some of the stuff, but it packs a punch in that simple implementation. I think compared to Unix ops, I would prefer, if I was using this arg parse style library, I would prefer using adopt versus Unix ops. This is just my opinion. Folks who have more experience with using Unix ops versus other command line parsings, if you have a different opinion, post in the YouTube comments and let's have a discussion on it and see what might be better. Are there questions? Okay, if there are no questions, I do appreciate. I'm sorry again for the late start today. Again, next week we are having a brief hiatus, we'll be back the following week. I hope you all have a good afternoon, good evening, and good morning, depending upon where you are in the location of the world today. I'll see you guys later. Bye.